All right, so obviously not looking too far ahead in my own note. It just says the next example is how to evaluate with your calculator. So I'll just give you a couple to make sure you can use your calculator. But if you were able to use the permutation button, then you'll have no problems with this, obviously. So just give you a couple here to go ahead and try on your calculator. Make sure you get the correct answer. But as long as you, if you did permutations, combinations are not a big deal. So you should get 116,280. Similarly, and there's no sense me bringing up a calculator because every calculator is different. So it's just as easy if you can't find the correct button or can't get the correct answer, just to come in and talk to me about it because it's just that much quicker. So if you can't find the button, don't fret too much about it. We'll look through your calculator tomorrow and get that. All right, so next example here. So how many different ways to get from A to B? And you're moving left and right. Sorry, right and down. It's so many people that say, well, what happens if I go backwards? Well, you don't go backwards when you're going point A to point B, or at least I don't. I try to get there kind of as fast as I can. I guess that's not true. Going to in-laws or something, I kind of drag my feet a little bit, but the whole point is to make it A to B as efficient as you can. So let's look at this in terms of a grid of the town. If this is where you live, and this is where the school is, how many different paths can you take each day? Well, the way you can do it is it's very similar to Pascal's triangle. If we go on the diagonal, so we look at it in terms of intersections, how many ways can you get to this intersection? Well, one way. How many ways to this one? Well, only one, because there's only one pathway moving right that I can get there. So what you'll find is, if we go to the intersections to the right, there's only one way to reach them. And that's by following that same path. Similarly, if we were to move straight down, there's only one way for us to reach each of those individual intersections. It's when we start turning and making changes in direction where things kind of change up. How many ways can I get to this intersection? Well, I can come from here and from here. So that means that 1 plus 1. There's actually 2 ways I can get to that intersection. So when you're doing these types of questions, what you want to do is you want to do a row at a time. So I'm going to move across to get to this intersection. Was 2 from this one and 1 here. So there's actually 3 ways to get to this one. 4, 5, 6, 7. Going to the next row, and now you start seeing the pattern. 3, 6, 10, 15, 21, 28. 4, 10, 20, 35, 56, and 84. Oh, what's going on here? 84, the next one. 5, 15, 35, 70, 126, 0, 1, is that 210? Carry that 1. Yep, 210. In the final row, 6, 21. We got 56, 6, 126, 2, 252, which leaves us with 2, 6, 4, 462. So therefore, if my mental math was correct, there are 462 different paths to reach point B. Now there is a shortcut to this, so I will tell you the shortcut. Shortcut, and this is the key. If the pattern is symmetrical, and that's the huge catch here. Okay, so the pattern has to be symmetrical, which basically means you have to be dealing with a nice shape. So it's a nice rectangle. So the shortcut here would be combination of, so you would add rows plus columns, I guess is the easiest way for me to write it here. rows plus columns. All right, so each row, so you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So for our example here, combination of 11, comma, and then you would do the number of columns. 1, 2, 3, 4, 5. And if you punch 11, combination 5, you get 462 as well. Okay. So it works nice if it's symmetrical. If it's not symmetrical, then it causes you a whole bunch of headaches. Okay, but it is a nice little shortcut for a lot of the homework questions. However, I'm going to put something like this on the test just to make it more challenging for you. It's always got to be a sport, right? If you can't get hurt, not much fun trying it. So, if it's not symmetrical, the shortcut doesn't work. Big deal. You have the strategy in place to deal with it. So I'm just going to run through this one quick. So basically moving straight across, 1, 1, 1, 1, and 1. So this intersection is a 2, that intersection is a 3, and I can't go any further. All right, next row would start here. Well, there's only 3 ways to get to that intersection, and that's by that pathway there, or that pathway, or that pathway. So there are the 3. Moving across now, that would get me there to 4. Kind of looking at the next row, 3, this one will be a 7, and then this one's an 8, and finally 1, and then this long forgotten 2 is going to come down to give me a 3, this will give me a 6, 13, and to get to there will be 21. So there's 21 ways to make it to that sort of bottleneck. Now, once you reach that bottleneck, instead of being 1s, it's going to be 21s across, because that's 21 ways to get to this junction point. So moving across would be 21s, and then moving down would be 21s. Moving into the middle, I'd have 42 there. To get to this one, there's only 1 feeder in there. That's 42. To get here, you would have 63, 42 and 21, also 63. Finally, you'd end up with 126 to get to point B. So therefore, it will take, well, I guess it won't take, there are. So therefore, there are 126 different paths. All right, so keep that in mind if you're a walker to school. Okay, if you have different paths to follow throughout the town, easy enough. You can change up your scenery quite a bit. 126 will get you through pretty much most of the school year, so keep that in mind. All right, so homework's listed here below. If you have any questions with the homework, you know how this works. I will definitely clear things up for you the next day, and good luck.